welcome back to today's ninth session on decision trees. As usual, let us do with help of a data set. Today's our data set is based on the e-commerce shopping behavior. So I'm pulling in the CSV reader because the data is available in this format. Let me connect the to the source of the data. So the data is now pulled into our environment. Now the data set that we are talking today is about the e-commerce website where the shopping behavior of the customers has been captured in terms of the pages that they have visited, the bounce rates, the exit rates, the days in which the customers have visited the site, and the region and the browser they have used, and are they returning customers, and these are some of the few features that has been captured as part of the data set. And let us pull in our data explorer to see how what kind of data that we have. So these are all the numerical values with respect to the bounce rates, exit rates, page values, special days, operating system, browser, region, traffic, and different kind of pages like the admin page, the information page, product page, etc. And then there are few categorical variables in terms of the month and the visitor type, weekends, or revenue. And then this variable is of our interest because this is going to be our target variable where we will be predicting whether based on this customer behavior, the features that are being captured, will the business will be able to predict whether this customer is going to generate revenue for it or not. So this is going to be our target variable, and based on all this input features that were provided with. Okay, without any further ado, let's start building our decision tree model. So before we build the model, first thing that we need to do is split our data set into training and test data. Okay, so for that we will use the table partitioner node. So I pull in the table partitioner node, connect the data source, sorry, and then we will use the 70/30 partition by default, and then we this time we will use the stratified partitioning strategy, sampling strategy, because we want to retain the sampling that we have, which is distributed across the data set. So once we have split the data set using the table partitioner. Now we have two partitions. The first partition with 8,000 8K records, the second test data with uh, the 3K records. Now let us pull in our nodes which will be used for the decision tree building. So decision tree learner is the learner. Decision tree predictor is going to be our predictor. And then to evaluate the efficiency of the model, we will need a scorer to calculate our accuracy. Let's start building our model now that we have our table partition. Let us connect the training data to the decision tree learner. One important aspect that we will have to configure is that, of course, the first one is the variable that we need to predict, which is revenue, and the next important parameter, that is the quality measure, which is Gini Index. So this Gini Index will help in deciding how the tree should be split, or like no on what basis the tree will be the data in the tree will be grouped into different categories, and then how this is carried forward. That is calculated mathematically with the Gini coefficient, and then that has been automatically calculated here mathematically. And the next one important variable that we need to configure is whether we are allowing pruning or we are not allowing pruning. So with no pruning, the tree will completely establish itself, and then it will try to fit all the data points, and there is a probability that this way the tree can become overfitting. But let us see how this actually pans out with pruning and without pruning in with our configuration. So let us start with the simple configuration. Like we have configured the Gini index and then we have set our pruning method as like no pruning. So let's see how the tree gets built. Now let us execute and see how the tree is being built. So if we take a deep look into how the tree has been built, now it has taken the first value, numerical value of page values, which this is an input variable that was used as part of the training that was given in the data set to first classify the group the data set, and then it expanded each of the nodes each, and then built a big tree based on the branches until the it reaches a point where the highest purity is achieved, where there is like no majority of the configuration falling into one similar data set as per our target variable. So you see the both the trees like no all like the trees are built as much as possible based on the configuration that was set. So this is a full build tree, and this is how the decision tree has learner has built the tree based on the data that is given to us. Now to see the prediction how the data decision tree has been built, let us connect it to the predictor and validate that with a test data. Here also we will do the configuration, and yeah, which is already set, and we will execute. Now let us see what is accuracy of this model, which is correctly set. Let us execute. If we see, the accuracy of model is 87%. Okay, now the tree has built completely because we have set a no pruning method. Now let us change a bit and then see how the tree will perform if we uh, set it as pruning. Now if we have set the configuration as pruning, because we have changed the configuration, let us re-execute the nodes and see what is the accuracy now. As you see, the accuracy has jumped from 87 to 89.7. This is so because now with no pruning, we are cutting off the trees. Now let us see how the tree has grown in a no pruning way. As you see, with the same variable, the tree has been cut off. The tree has not populated to the extent that it was growing in a without pruning. Now, the pruning was done as much as possible to arrive at the purity node, the leaf node, which has the better purity. So it is always important to look at the performance of the test data, because we don't want to achieve a highest purity with the training data, because this can lead to overfitting. That is why it's better to use the pruning to avoid this overfitting. So there are, to summarize, there are two important aspects that we have to remember in building any decision tree. So the decision tree uses the ones that we have seen. The decision tree generally uses a Gini index that will help in splitting the tree, into different branches until and this is an iterative process until it reaches the highest purity of the nodes. And the next one is that because the decision trees are very prone to overfitting, it is important to use pruning so that the tree is like the tree is less overfitting, which means it is more generalized to validate, predict our test data. So these are the two important things that we need to consider, and this is done. This overfitting can be achieved by pruning the tree. That is why we have seen like without pruning, the efficiency of the decision tree was like 87, and with pruning the efficiency has improved to 87, 89. So because the tree has learned not to overfit by pruning. Okay, thank you for watching. See you in the next video.